We're given some information about two stocks X and Y. We're given the expected returns of those two stocks. We're given the volatilities, which is the standard deviations, um, and correlation coefficient of these two. And we are given the expected return for a portfolio consisting of these two stocks, which is 12%. And we want to calculate the volatility, which is the standard deviation of the portfolio. So to calculate the volatility of the portfolio, we have to know how much stock X and Y are in the portfolio. And we can note this, we can calculate this by using the expected returns for this portfolio. So we know that expected return of portfolio equals weight of X times expected return of X plus weight of Y times e to the, expected return of Y. So we're given that the expected return of the portfolio is 12%, and we don't know the weight of X, so I'll just leave that as WX. And we know that the expected return of stock X is 10%, so I'll put 0.1. And we know that there are only two stocks in the portfolio, so we can put the weight of Y as 1 minus WX. And we're given the expected returns of Y as 15%. So I'll put 0.15. And if we calculate this, we get a W as 0.6. So what this means, in the portfolio, there are 60% of stock X, and consequently, we have a 0. Stock Y's weight in the portfolio is 0.4. And to calculate the variance of portfolio, the formula for the variance of portfolio is weight of X squared times variance of X plus weight of Y squared times variance of Y plus 2 times correlation coefficient times weight of X times weight of Y times standard deviation of X times standard deviation of Y. And we know all these values, so we just need to plug in the values. As I mentioned earlier, we have 0.6 for the weight of X in the portfolio. We square that, and we're given the standard deviations of 18% for stock X. So for variance, we have to square that too. And so I'll put 0.18 squared for variance of X, and we have 0.4 for weight of Y, and we square that, and the standard variance of Y is standard deviation of Y squared. So, and we are given that the correlation coefficient is 0.25, so plug in that, and we plug in the weight of these two values, and plug in the standard deviations as well. So if you calculate all these values, you have 0.011664 plus 0.4, 0.0064 for the second term, and for the last one, it's a little long, but 432. And if we add all these up, we get 0.02234. 0.384. And to calculate the standard deviation, we square root this variance, which is 14.96%. So the answer is D.